Hello guys, welcome to H2O, the A to Z of chemistry. I am Dr. Ritu Johar, your educator for this course, the atomic structure. Today we will begin with lecture 2 from the course. And in the last lecture, we had discussed about the history of the atom till the Dalton's atomic theory. And we will move ahead from there and we will discuss the discovery of the fundamental particles. Here we will be discussing in this lecture about the electrons, the cathode rays, basically because the cathode rays are what is a beam of these electrons. In this we would be discussing about the cathode ray tube experiment, the properties of cathode rays and so on. So by the end of the 19th century, there were several experiments being done, and these indicated that the atom can be subdivided and it contains certain fundamental particles. Chiefly, the three fundamental particles of the atom were the electron, proton and neutron. But till date, about 35 subatomic particles they have been discovered. For example, we have neutrino, meson, antiproton. There are many, there are 35 of them. But these are not in our syllabus. So we would be focusing our study upon basically the electrons, protons and the neutrons. So now, one of the most important limitation of the Dalton's atomic theory was that he could not explain the electrical nature of matter, and it was established quite early that electricity is produced when substances like glass or ebonite, they are rubbed with silk or fur. And this indicated that the matter is electrical in nature, but Dalton could not explain that. So it was basically first of all explained by Michael Faraday when he passed electricity through the solutions of certain substances called as electrolytes. And these electrolytes, when electricity passes through them, they decompose to give the constituent elements by the process called as electrolysis. So the phenomenon of the decomposition of an electrolyte with the help of electricity is known as electrolysis. And Faraday's experiments, they revealed that the matter has an electrical nature. He gave the laws of electrolysis, and these are known by his name, the Faraday's laws of electrolysis. And these basically laws, they provide a quantitative relationship between electricity and matter. We will be discussing all of this in a course called as electrochemistry in class 12. But for now, this is only just important for you that he proved that there is some relationship between matter and electricity, and these laws, they made us realize basically that electricity is made up of discrete particles. And it was later on that Stoney called these particles of matter to be electrons. However, it was not Stoney who discovered electrons. The electrons basically were discovered by J.J. Thomson. So let us study how the electrons were discovered. So experiments were being conducted at the end of the 19th century by various scientists like William Crook, Julius Tucker, J.J. Thomson, and they were doing experiments basically on the electrical conductance of gases at very high voltage and very low pressure, because the gases, they do not conduct electricity. They are bad conductors of electricity. So they were trying basically to check the conductance at a very high voltage and very low pressure. And this they did in the so-called cathode ray discharge tube experiments. This is the diagram of the cathode ray tube which was used for these experiments. And basically this is a glass tube. it has two metal strips fitted at the ends, and then it was sealed, and it has a side tube fitted with a cork, and this could be attached to a vacuum pump so as to adjust the pressure inside the discharge tube according to the gases they were taking, right? And then there was a gas which was filled into this tube so as to check the conductance of electricity through it. And the electrodes, they were connected to a high voltage generator, and the generator could generate a voltage as high as 10,000 volts as it was required for the experiment. And the electrode which was connected to the negative terminal of the generator was called as cathode, and the one which was connected to the positive terminal of the generator was called as anode. So this is basically the construction of the cathode ray tube apparatus. And then the experiments they did revealed the emission of certain invisible rays from the cathode, and these rays were called as the cathode rays. And then Sir J.J. Thomson was the one who studied the properties of these rays in detail, which led to the discovery of the electron. The cathode ray tube is also called as Crookes tube because William Crookes was the first person to study the conductance of electricity through the cathode ray tube, right? And so when the sufficiently high voltage was attained, they saw the following results in the experiment. The first one was that no electricity flows between the electrodes at ordinary pressure because the gases, they are poor conductors, right? And the second was that when pressure was reduced to about 10 power minus 2 atmosphere, at that time the electricity started flowing, plus a colored glow was observed in the tube. And the color of the glow, this depended upon the nature of the gas which was taken in the discharge tube. For example, the neon advertising tubes, they are based on this property and they give a reddish orange light. And then the pressure was reduced further to 10 power minus 4 atmosphere. And when this was reduced to this much a pressure, this is a very low pressure, the current continued flowing, but the light emission stopped. And what happened was that the glass wall at the back glowed when the anode was perforated. So here we have a perforated anode now, and there the glow was seen at the back of the anode when this was perforated. The light from the cathode, this traveled, crossed the perforations in the anode and reached the back. And why this was glowing was because there was a fluorescent or a phosphorescent coating over here, that was the zinc sulfide, and the fluorescent materials, you can say phosphorescent materials. There is a slight technical difference in the two, but we will not discuss that now. So we can use either of the terms for the present moment. So the phosphorescent material, so these have a property basically that when some highly charged particles coming with a high velocity, they strike at the surface, they produce a spark, they produce a glow, and this glow or spark is called as scintillation. Okay, so the glass wall with the perforated anode, this started glowing, right? And as the glow was coming from the direction of the cathode to the anode, so these were called as cathode rays. So now, although William Crookes was the first to study the conductance of electricity through gases, he established that the gases could conduct electricity at a very high voltage and a very low pressure, but he could not establish the reason for the conductance of this electricity. And this was done by Sir J.J. Thomson, and it is through his study we came to know about the properties of the cathode rays. So let us quickly discuss what are the properties of the cathode rays. The first one is that the cathode rays cast shadow of solid objects placed in their path. So this is the diagram. So we can see that we have placed a solid object in the path of the cathode rays and a shadow is being cast of this object. And during the experiment, this was seen that the fluorescence or the flash of light, this was observed in the region outside this shadow. Okay, so above or below, but it could not be seen here. So this showed basically that the cathode rays, they are going to travel in straight lines. And as the shadow was cast behind the anode away from the cathode, this showed that the cathode rays, they travel from cathode to anode. And then they cause the rotation of a light wheel placed in their path. So this was a light paddle wheel which they made of a very light metal like mica, and this was so light that the cathode rays could cause the rotation of this light wheel. So basically, if it is causing a rotation, this showed that the cathode rays that had a particle nature, plus they had a high kinetic energy, which is causing the rotation of the light paddle wheel. The next property is that the cathode rays, they are deflected towards the positive plate when two charge plates are placed on each side. So let us see this also with the diagram. So basically, these are the two charged plates which have been placed on the side of the cathode ray tube. And when the electric field is applied, so we see that the cathode rays are bending towards the positive plate. Okay, so this basically showed that the cathode rays, they are negatively charged. And similarly, when the cathode rays are placed in a magnetic field, so we are placing a magnetic field, they again get deflected under the influence of the magnetic field, and this again shows that the cathode rays, they are charged in nature. Then the cathode rays could heat a metal foil placed between the electrodes. So this again showed that the foil, if it is getting heated by the cathode rays, that the cathode rays, they have high energy, plus they have a heating effect. The next is that the cathode rays, they could ionize the gases through which they pass. So this, what is this going to mean is basically that the cathode rays possess kinetic energy and they are composed of material particles, and when they pass through a gas, the energetic particles of the cathode rays, they attack the atoms of the gas and force them to get ionized, right? So the next was that they could produce X-rays when they strike against hard metallic surfaces like tungsten, showing that they are highly energetic. Like ordinary light, they could affect the photographic plates. We have already discussed fluorescence, that cathode rays cause fluorescence, flash of light when they strike substances like zinc sulfide. Then they could penetrate to thin sheets of metal and mica, showing that they even had a penetrating power. And then they could cause chemical changes. For example, they have reducing effects, which also we would be studying later on in our other courses. And a very important thing, that the cathode rays, they have the same charge to mass ratio, which is denoted by E by M ratio. So whatever the nature of the electrode was, whatever the nature of the gas which we had taken in the tube, the cathode rays, they had the same charge to mass ratio, and this was calculated by Sir J.J. Thomson in one of his experiments, which we are going to do just now. And this was very important, that the cathode rays, all of them, whatever nature of the material of the cathode electrode or the nature of the gas contained in the tube, they were having the same charge to mass ratio. And the last property was that whatever, apart from the EM ratio also, whatever were the characteristics of the cathode rays, basically the cathode rays being particulate in nature, and these particles, they were called as electrons. So the characteristics of the cathode rays or the electrons, they did not depend upon the nature of the material of the electrodes or the nature of the gas enclosed. So this is a very important thing that you should remember, that the cathode ray nature, the characteristics did not depend upon the nature of the material of the electrodes or the nature of gas enclosed. Now, doing all this, probably you must have thought, where are these cathode rays coming from? What is the origin of these cathode rays? What is the source of these cathode rays? Well, the cathode rays, first of all, they originate from the material of the cathode, that is the material of the negative electrode, which is attached to the negative terminal of the voltage generator. And then electricity, we know, even Faraday had given it to us, that electricity is made up of some particles, and these were the particles which were coming from the negative electrode to a negative terminal of the battery to the cathode, and from the metal, the excess electrons, they were being emitted out. So this was the first origin of the cathode rays. And then these negative particles which were coming out from the material of the cathode, they were striking against the gas which was present inside the discharge tube. And then the bombardment of the gas molecules by these high speed particles called as electrons, they more of the electrons were being emitted from the gas molecules, and this being the second source of the cathode rays. Okay, so we have basically two sources of the cathode rays or the electrons in this experiment, one being emitted from the cathode and then being emitted from the atoms of the gas molecules. And since the cathode rays or the electrons, they were having the same characteristics irrespective of the nature of the material of the electrode or the gas, we can conclude that the electrons, they are the basic constituents of all atoms. And now, having discussed all things, what are the two most important results, most two important properties of cathode rays? One is that the cathode rays, they are made up of material particles, and the second is that they carry negative charge. Thus, we can say that the cathode rays, they are composed of negatively charged particles called as electrons, and the name electron was suggested by Stoney, and the modern name for the cathode rays is electron beam. So now let us study how Sir J.J. Thomson determined the charge to mass ratio of electrons. He used a cathode ray tube which was quite similar to the TV picture tube, and this he used to measure the ratio. This is the apparatus he used, and it is essentially the same cathode ray tube which we have studied earlier, and the only difference is that the anode, this has a small hole in the center, so that when the electrons, they are generated from the cathode and they accelerate towards the anode, some of these electrons, they can pass through the anode and strike at the phosphor screen which is placed behind, and when they're going to strike, the glow is going to be produced because of the phenomenon of phosphorescence. And then he fitted the neck of this tube with a magnet and a pair of metal plates which could be given electric charges. Okay, so this is essentially what is the apparatus, and then he applied both the electric field and the magnetic field perpendicular to each other as well as to the path of the electrons. And in the absence of any field, this beam of electrons is going to pass through the hole and strike at a point straight in line with this hole, say this at the point B. And when under the influence of the electric field, there is going to be the bending of this beam towards the positive charge plate, and this strikes at a point, say at A. And when only under the influence of the magnetic field, it was seen that it fell on the point C, which was opposite to the direction of the electric field, right? And then he carefully balanced the two and made the rays follow the straight path as it was in the absence of any field, and then again making it fall on B. And he realized during all these experiments that the amount of deviation of the particles, any particle, not only electrons, but any particle, from their path, they do deviate in the presence of the electrical or the magnetic field. And this amount of deviation depends upon several factors. First is that if the magnetic field is generated at right angle to the electric field, the particles get deflected in a direction exactly opposite to that caused by the electric field only. And we saw this in the case of electron also, that we place the electric field and the magnetic field perpendicular to each other, and whatever was the bending of the light in case of the electric field, the magnetic field bending was exactly opposite to that. And then if the charge of the particle, that is more, the magnitude of the charge of the particle is more, there is going to be more interaction with the electric or the magnetic field, and hence there is going to be more deflection. And then there is a relationship between the mass of the particle and the deflection. Lighter the particle, greater is the deflection. Plus the deflection of the particles is going to be more if the voltage across the electrodes is increased or the strength of the magnetic field is increased. So these all factors, they affect the amount of deviation of the particles. So this all he studied, he realized this while he was doing all these experiments. So finally, by carrying out accurate measurements on the amount of deflections undergone by the particles on the electric field strength and on the magnetic field strength, Thomson was able to determine the value of the ratio of charge over mass of an electron. And this is known as the E by M ratio, that is charge to mass ratio. And he found this ratio to be 1.758820 into 10 power 11 coulomb per kilogram for an electron. Okay, and this he calculated using different discharge tubes fitted with electrodes of different metals also, and then he placed different gases in the tube also, and he found every time that the ratio of the charge to mass of the electrons, this was coming to be the same. But now J.J. Thomson, he was not able to find the absolute value of the charge or the mass of an electron, and it was Robert Millikan who determined the value of E by his oil drop experiment. So we will also learn what was this oil drop experiment. So this is the diagram of the apparatus which Millikan used in his oil drop experiment to calculate the electric charge on an electron. So let us first of all understand the apparatus and then the working. So this was basically a very simple chamber which consisted of two metal plates. They were placed parallel to each other and they could be electrically charged. And the top plate, this had a very small hole in the center. And then there was an atomizer which could spray a mist of very fine oil droplets into the chamber. And then there was a X-ray beam provision to irradiate the space between the two parallel plates and a telescope to see the movement of the oil droplets which were going to come through this hole. So this is basically the construction. And then what did he do? Basically what he did was that he sprayed a fine mist of oil droplets above the charged metal plates. The top one, I have shown that it had a tiny hole in it, and some of the oil droplets, they passed through the hole into the spaces, and this hole was so small that only one droplet could come at a time. And then the rate of the fall of these oil droplets under gravity, this was viewed through the telescope, and this was equipped with the micrometer eyepiece. And through this he was able to calculate the mass of the oil droplet. And then he irradiated the space between the plates briefly with X-rays, which knocked out the electrons from the air, thereby giving them a negative charge. And the fall, basically these electrons, they were picked up by the oil droplets. The oil droplets became charged, and now the fall of these charged oil drops he controlled by applying a suitable electrical voltage. And hence he controlled the movement. He could retard the oil droplet fall, he could accelerate the fall, and even make the oil droplet stationary. And by carefully measuring the effects of the electric field strength on the motion of the oil droplets, he found that the magnitude of the electrical charge Q on the oil droplets, this was always an integral multiple of the electric charge E, which the value he found was minus 1.60 into 10 power minus 19 coulomb. So this means that the oil droplet all were having different charges, but basically the charge was a multiple of this number. It could be 1, 2, 3, whatever, but it was always a multiple of this charge, which was minus 1.60 into 10 power minus 19 coulomb. So this was the charge he found. And today this can be calculated with a more accuracy, and this is found to be minus 1.602176 into 10 power minus 19 coulomb. And the mass of the electron, this can now be calculated by combining the results of the Thomson's E by M ratio and the charge found by Millikan, right? So the mass of the electron would be the charge divided by the E by M ratio. So you know both of them, so you can calculate the mass of the electron, and this came up to 9.102 into 10 power minus 28 grams, or 9.102 into 10 power minus 31 kg. And the mass of the electron, this is so small, this is approximately 1837 times less than the mass of a hydrogen atom. Hence it is practically negligible. This mass is so small that while calculating the mass of an atom, we do not count the mass of an electron. Even if you see on the atomic mass unit scale, the mass of the electron is 0.000548. So if you add the mass of these electrons to the mass of an atom, this is not going to make much of a difference. An electron, this has the smallest charge, electrical charge possible. So this has been given a unit negative charge, and hence we can define an electron to be a subatomic particle having a unit negative charge and mass which is 1 by 1837 times that of a hydrogen atom. Now there is a section we have built up in almost all our lectures, where that is have an edge section, where we are trying to put up things which are very important for the competitive exams, a recap of things which are given in the lecture, or some extra things which can help you excel in the exams, have an edge over the other students. So the first thing is we are discussing here is the mass of a moving electron. Basically, we have calculated the E by M ratio of an electron. So this can vary when the electron is moving, and this varies with the velocity according to the relationship that M is equal to M naught by under root of 1 minus v square over c square, where m is the mass of the moving electron, m naught the mass of the stationary electron, v the velocity of the electron, and c the velocity of light. And if you solve it further, you will realize that the mass of a moving electron is higher than that of a stationary one, multiplying with the velocity of light. Therefore, the specific charge E by m ratio of a moving electron is lesser than that of a stationary one. And plus the electron charge, it is the smallest known electric charge and referred to as unit negative charge. So now let us quickly recap some important facts about the electron. So first we have is the charge. This is minus 1.602 into 10 power minus 19 coulomb, and this we determined by the Millikan this was determined by Millikan in the oil drop experiment. Then the mass of the electron 9.11 into 10 power minus 31 kg. This was calculated by J.J. Thomson using the E by m ratio and the charge calculated by Millikan in the oil drop experiment. Then the specific charge EM ratio, that is minus 1.76 into 10 power 8 coulomb per gram, and this decreases with increase in velocity of the electron, because the increase in velocity increases the mass of the electron. And then we have the density of the electron. This is 2.17 into 10 power 17 gram per centimeter cube. And if an atom or a group has higher electron density, this means that there is some aspect of the molecular structure, like there is a resonance or inductive effect, which we will be studying in organic chemistry. This effects, they cause a shift of the negative charge towards some specific spot in the molecule where the density of the electron is going to be more. Then we have the radius of the electron. This is 10 power minus 15 centimeter. If you calculate the mass of 1 mole of electrons, that would be the mass of 1 electron multiplied by the Avogadro's number. This comes up approximately to 0.55 mg. And the charge on 1 mole of electrons, this is minus 96500 coulomb. This is also called as 1 Faraday, and this value is 1.758 into 10 power 11 coulomb per kilogram. So I hope you have understood all these things. They are very important. Please try and remember all these values. They are very important. They are asked in the examinations. You are going to use them in many numericals further in the course. So please remember all of them very well. So that would be the end for this lecture. I hope you had a nice time. You enjoyed studying the discovery of the electron with me. We discussed very important topics in this lecture. If you have any problem, you have any comments to give, you have any suggestions, you want to discuss anything which you are facing a difficulty with, you can mail us at h2ochemistry@gmail.com. If you've liked the lecture, please do upvote for it by clicking on the like link, and also do subscribe to our channel so that you get information whenever we put up a new course for you, a new lecture for you. Click on the bell icon, you will get the notification immediately. Bye for now. We will be meeting again for the next lecture on the discovery of protons and neutrons in the course Atomic Structure from the channel H2O. Bye bye.